identity native infrastructure access and what that means in today's kind of cloud environment. So what we're going to talk about is how breaches typically happen, how identity native infrastructure access works, and specifically how Teleport works at a more technical level. And then we're going to do a little bit of a case study and show how Teleport's being used in the wild today. So first things first, you have your breach. We found that every breach has two things in common. First, there will be a human error for that initial infiltration. And then there'll be an attempt to pivot to maximize that blast radius and get the most out of that infiltration. So this is how they always look, 99.9% of the time. So what happens is a hacker gains a foothold. This can be a leaked secret in a GitHub repo. This can be a phishing attempt that they got a password from an email. And then they pivot. They take that access and they get into more and more and more and more systems until your entire infrastructure grinds to a halt. And then you're spent cleaning up that mess. And it can cost, millions of dollars. And it's just also embarrassing, frankly, from a PR standpoint. No one wants to be the person that got hacked. So how does Teleport and how does identity native infrastructure access play into all this? Well, the first point is that we do identity for everything, and this is key. It's not just your engineers, it's not just your humans. We have identity for machines, we have identity for microservices, for applications. And this is key in order to secure your infrastructure completely. The next step is that we have device security. So we have this cryptographically validated identity, but in order to truly protect that on the device level, what you need to do is work with the hardware. So what Teleport does is that it secures your identity in the secure enclaves that already exist on your device. So we're talking things like TPMs, HSMs, even Touch ID on your Macs, for example. And so even if someone came up to you in a coffee shop, you're in line for your coffee, someone comes up to you and bonks you on the back of the head with a wrench. They take your laptop. They will not be able to access your identity because of the way that it's stored at the hardware level. And so going back a little bit with Teleport and identity, we actually started as an identity native product. So we built Teleport to solve our own access issues. We built it to solve our own access issues that we were running into internally. And when we'd go into sales calls, people are like, okay, yeah, your main product, that's fine, but what's Teleport? Can we buy that? And we're like, okay, maybe we've got something here. And so nowadays, companies are trying to, everyone's going identity native, and it became this kind of buzzword, right? Identity, identity, identity. But Teleport is one of the few companies that actually had it built in from the ground up. And now companies are trying to kind of identity wash their own services. But at the end of the day, what a lot of these look like under the hood are the same old secrets, the same old passwords. And these are things like, like password vaults, for example. It's just not good enough anymore. Next, we have proof of presence. So this is also very important. Say you're in a similar scenario. You're, someone bonks you on the head with a wrench. You just don't learn. You just start wearing a hard hat. They take your laptop. They cannot log in to your infrastructure, even if you had previously logged into it, because you need an MFA session every time that you log in. And we'll talk a little bit more about how that looks when we go over the technical aspect. The next part is mutual authentication. So it's not enough to secure the initial infrastructure access. You actually have to secure the connection as well. And what Teleport does is it uses mutual TLS connections for every resource to every engineer and to every machine to machine. And with this connection proxy, this keeps all of your data and all of your session activity secure even when it's moving. So how does Teleport work? So this is a little overview and a little high-level architecture diagram. So at its base, Teleport consolidates all of your different infrastructure access into one single platform. And this platform, you can access, you have databases, you have Kubernetes clusters, you have SSH nodes, you even have Windows boxes. Yeah, we support Windows, which is always fun for our developers. So the two parts of Teleport are you have the proxy, the identity native proxy, and you have the auth service. So the proxy is the first touch point. The proxy is what connects the user to those infrastructure resources. And the infrastructure resources connect to the proxy. All you have to do is open up a single port. So you can still have air-gapped environments. They don't need external egress. All you need is that one port open to talk to the Teleport proxy. From there, that connection is reverse proxy tunneled out to the user, out of the network. And that is all, again, done with mutual TLS encryption and connection. The next aspect you have is what we call the auth service. And so there's two subcomponents. You have the audit log, and you have the certificate authority. The certificate authority is what issues and renews those short-lived X509 certificates to your users or to your machines. The audit log is what encapsulates all of your audit, no matter where you are, no matter what region you're in, no matter what resource you're accessing. In the past, if you had on-prem resources, you had cloud resources, you had GKE, you had AWS. All of those logs were handled differently, and you'd have to kind of muddle them together yourself. With Teleport, all of that logging is done completely in the same place and already aggregated for you. So you can easily exfiltrate it and go from there. And so that's kind of how Teleport works at a high level. A user will try to access a piece of infrastructure. They'll authenticate with your SSO, so whether that be GitHub, GitLab, whatever you're using, Okta. And then that tells us, OK, now we know who you are, right? We've confirmed your identity. Then Teleport says, well, what are you allowed to access? And once you're inside of that resource, what are your permissions while there? And that's all done through these concept of a Teleport RBAC roles. And these RBAC roles have a one-to-one mapping with other users in your infrastructure. So you can map a Teleport RBAC role to an AWS IAM, for instance. And you can share that IAM role between multiple users while still maintaining that chain of custody with who's doing what. Because at the end of the day, it maps to your own identity. So some of the benefits of Teleport are you have this single source of truth. So in the past, like I said, you'd have all these different ways and all these different kind of motions of accessing all your different infrastructure. With Teleport, there's no need to second guess anymore. Everything is single source to the Teleport RBAC roles. So you know exactly what user permissions you have per resource. You also have your zero trust infrastructure access. So we employ all of the zero trust model specifics in Teleport. It's the easiest way to implement this beyond core and zero trust kind of model. All the connections from any engineer or machine user they're all authenticated, they're all authorized, and everything is audit logged so you can audit and achieve those compliance standards. It also renders phishing and pivot attacks completely useless. Because there's no long-lived credentials here, there's nothing to phish. There's nothing to steal. Even if you had the least trained employee in the world who loves clicking those links, I want an iPad, I want more coins for Candy Crush. It doesn't matter because they have nothing to give. They have no passwords to be stolen. All because they're using those short-lived X509 certificates to access all of their infrastructure. It also reduces audit and compliance burdens. Because everything's audited in the same place and those user controls are so granular and so easily apparent and readily available, it makes auditing a breeze. And this is what a lot of companies use Teleport for initially. So there's two options to get started here. There's the Community Edition. So we're proudly open source, open core. And there's no security limitation. So it has still the same security standards that we would put into our Enterprise Edition. And some companies do use our open source in production. It's identity native and still zero trust compliant. We also then have the Enterprise Edition. So this is what companies typically want to use when they start scaling. It has more SSO integrations. You can use a wider variety of those. And it has a little bit more granular access. It has FIPS compliance. So if you do need to achieve those higher compliance standards at scale, you're probably going to want to use the Enterprise Edition. So we connect to your infrastructure. That's the most simple way to put it. It's the easiest and most secure way to access your infrastructure. So we have a couple different protocols available. We have SSH. So this is like one of our most basic offerings. It allows you to SSH into any node, no matter where you are. with kernel-level logging and enhanced session recording. So you can actually play back these SSH sessions, and you can also do moderated sessions. Next, we have Kubernetes access. So this is one of our other cornerstones and kind of how Teleport got started. You can automate access provisioning and request approvals across all your Kubernetes clusters using your favorite programming language, whatever. It's extremely extensible and very easy to get started. Because if anyone here has managed Kubernetes RBAC themselves, it can be a real hell. We also have database access. So these database access, it's still audited in the same way. Every query you run, no matter what user they're assuming, all of that maps back to their original identity. So say a user in your Mongo database, like their user shared dev, executed a bunch of drop table commands. With Teleport, you'd be able to track that to the exact engineer that did that, or the exact account that was compromised in that case. We also have Windows access. So you can access Windows RDP. And again, these sessions are recorded, and you can also do moderated sessions to access your secure Windows servers. So a very validating thing for us is actually when companies use this in production and have these success stories. So DoorDash started like a lot of our initial customers do, in that they tried to build this access solution themselves. And this is what I get a lot when I talk at these kind of conferences. It's like, well, can't you just build a certificate authority yourself? And the answer is yes, you can. But what does that look like 3 years down the line when you started with 10 engineers and now you have 200? You hit a great Series C funding and now you guys are to the moon. How are you going to scale that infrastructure access with this kind of spaghetti code that you've written? It becomes very painful. And this is how DoorDash started, like a lot of these companies do. It's easy to manage infrastructure access for a handful of employees, right? 1 or 2 engineers. It's not hard. It's really not. When you get to 40 employees and you get to 200 clusters, you get to 2,000 clusters, and you have databases, and you have these SSH nodes, and you have Windows boxes that you need to RDB into, how is your own homegrown solution going to hold up? So DoorDash realized that they had this exact problem. They had this homegrown solution, and then they started scaling quickly. They started getting investors. They started getting funding. Just grow, go, 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 go. And they found out that their solution did not work. So instead, what they did was they talked to us, and they started using the open source version of Teleport, tried it out, they really liked it, and they upgraded to enterprise. And now they're one of our biggest customers and have had a huge success with this. And they're able to scale their infrastructure access very easily and very securely. So the bottom line is that engineering productivity with security done right. That's what Teleport is. The most secure thing has to be the simplest. We don't get in the way of your engineering workflows, because if you did, they would not use us. I've been in companies way in the past, that had this security thing set up that engineers would just build workarounds to. They started saving passwords directly to their laptops in like a sticky note format. If it gets in the way of your engineer's workflow, they will not use it. And that's where Teleport comes in. We make it simple and secure, and those have to be the same thing. Otherwise, people are going to do workarounds. We're completely identity native, and we eliminate secrets and pivots. There is no long-lived credential anywhere in the Teleport ecosystem. We completely are compatible with like your biometrics, for example. So if you want to log into all your infrastructure using your Touch ID, you can do that. You can do that easily with Teleport. We consolidate access. So no more are you going to have all these different access planes. It's all in one place. So there's a lot less manual configuration and a lot less that can go wrong. And when things do, you can very easily narrow it down. And it's modern security. It's lightweight. It's not bloated. And it's exactly what you need to kind of get your stuff going and get your security right and secure. Get your security right and secure. What a great motto. But that's kind of the idea, and that's what Teleport's all about. So come check us out at our booth. We are down that way to the left. I think we're 2147. 2140. Come check us out if you want to talk more, and if you're interested, learn how we can get you started with Teleport. But thank you so much, and take the session survey in the mobile app if you get the chance. Thank you. Enjoy the rest of the conference.